So this talk is on minimal APIs. I don't know if anybody's used the minimal APIs yet. Just put your hand up. Ish. Okay, cool. They've been around since like a year and a half since that preview of .NET 6. But they keep the .NET 7 is expanding quite a lot onto these. So this is going to go through all the .NET 6 features and then the .NET 7 features on the end of it as well. So this is a bit about me. I work at a company called Codat. I'm a principal software engineer there. I mostly write in C# and JavaScript and TypeScript, but I do a bunch of other things like blog, a tweet, and random other things. So if you ever want to kind of get in contact with me, it's probably best way is on Twitter, because I'm always on there. Just send me a direct message if you've got any questions. So tonight we're going to cover kind of the normal traditional APIs and what kind of they involve. A hello world application and minimal APIs. They're going to go into the configuration of it and how you can configure the web application builder. We're going to the routing and how you route different requests in and deal with all them kind of routing concerns. We'll go into how we can bind models, kind of like typed models from our request, and then how we can actually put typed responses back to the package JSON. And then we'll go on a bit about authorization, and then the new .NET 7 features, and then a bit on testing as well to cover it off. So, to start off with traditional APIs. So I'm not going to talk about the really, really old stuff like the HP handlers and all that kind of rubbish. This is the new MVC traditional APIs approach. So we usually have three parts. We have the program CS, the startup CS, and the MVC the controls in the MVC stack. Your program CS kind of looks like this. So you have a main which calls a create host builder. And then that just calls a create default builder with a configured web default host defaults, and it just does lots of magic for you. So to start off with, the create default builder sets a bunch of paths, so it knows where to find the files on disk. It also configures the iConfiguration for .NET, so how it kind of sets up like getting the environment variables and the settings JSON file and your settings.environment.json files. So it does all that for you. It also configures the logger and does some validation stuff on the scope as well. And then the configure web host defaults sets Kestra up as the default web server unless there's INS in place. It sets up some host middleware filtering stuff and also sets up like the default forward headers if they're enabled by that ASP.NET Core forward headers as well. So there's a bits and bobs to do that kind of default setup of your application for your API, which most of the time you don't really care. And then if you want to plumb extra stuff on top of that, you need to add them into these places. So if you want to add different login, you put userlog or anything else hangs off the create default builder. And then if you want to kind of add your own app configuration, you can add that on as well at the end as well to the builder. And then the startup CS, which probably everybody's familiar with, it gets the iConfiguration plumbed into it. And then you can then set up your services. So this is the IOC configuration. So we can add our controllers, add our transient dependencies, and anything else we want to put in there. And then we get to configure the middleware as well. So this is the ASP.NET Core middleware. So you can say if it's in development, use the exception page. If not, just skip over it, use HPS redirects, and use routing, and use endpoints, and map their controllers. So, and then the controllers like this. For the routing, we have these cool things here, which are the attributes where you can just say, route it to anything what the controller's named. So this will be event. And then on the back of that, we got a get, and then we got another get with a /event ID as well. So we can configure all them. And there's another way to do this as well with convention-based routing. So you can use endpoints and you can map a default pattern to it here, which used to be really common in MVC3. And then people used to get really confused where the hell all their kind of routing's going. And then we went back to using attributes because this is not a really nice approach, I don't think. So there's a few problems with the kind of traditional APIs in .NET. We don't really have any views in MVC for APIs, even though it's called Model View Controller. So it kind of It isn't really that pattern, but we're kind of jamming it into that kind of pattern. Routing is really hard to diagnose in larger applications, so there's a bunch of tools out there to actually inspect the requests coming in and tell you where it's being routed to. So if you've ever tried to diagnose the routing inside of ASP.NET Core application or an old MVC application, it becomes really hard work when you've got lots of routes that are really similar. There's a bigger barrier to entry compared to Flask and Express. Them kind of frameworks are very simple. What it says is what it does. So you can just read top to bottom and you can see the routes and everything else and how what responses are getting passed back. So people coming into the .NET industry from other boot camps and things like that where they're using Express for Node, they find it really hard to kind of understand what's going on under the hood, because when you try to say, oh, we just need to change this to add another bit of extra response to that events endpoint, we want to have the duration, for example, you need to know how magically the control gets wired up, what the attributes are doing, everything else, lots of stuff, what the framework does by default without so you have to learn lots of stuff before you can get going. And there's a lot of boilerplate code as well that you saw in the program CS. It's improved since .NET Core 1.1 with all them default things, but before you used to have to wire everything yourself. So this is where minimal APIs come into play. These kind of try to solve all these problems. So you can start this in a normal console application to start off with, and then you can just change the SDK of it to just say .web, and that'll give you all the web SDK stuff for MS Build and all your references and things like that to ASP.NET Core. And then once you've got that, you can just create this builder. So you can do var builder, assign it web application.create builder, and that'll give you a builder instance. You can then call build on it, and then on the app where you get from building it, you get a bunch of things that you can just map onto. So you can do map get, so just map the route to hello world, and then just call run. And then that is as simple as the application can get. You can also use standard methods as well. So if you've got methods declared somewhere else in some other classes, you can also just kind of get that method and just pass it in as an argument into the app, the map get. And then the configuration and login and services all hang off of the builder as well. And we'll go into that later a bit more. So I'm just going to show you a quick demo of that getting started. So I have this little Hello World application. So this is literally just a console app, so I can just... So if I just go run this, it'll just give me Hello World to start with. Should do. There you go. Zoom in a bit. So what we can do is just change this Hello World application to be the .web SDK. And then we can start using the web application create builder. These arguments are what passed into if you've got a program class and you've got a main method, them args are just being passed in directly into this function just magically. So they're kind of just a variable that kind of just exists. So you can pass them down into it. So then we can do build.build. We got this app. And then we can then run that. And then we can just then map some things onto it. So we can just do it. So then we can get rid of this. Yeah. So we've got that. And then we can just run that, and it'll spin as a web server up for us. So it's already started. We can then go to this endpoint. And it'll just work straight away. And we can also add in some extra routes into here. So you can pass a different one in to restart it. This endpoint still works. Then if you do dotnetsheff on the end of it, we get hello Sheffield. So it's really easy to kind of get going and spin something up. So continue. So that's like a really simple demo of a Hello World application, but we're going to kind of build on that to kind of understand how we can get different routes in and responses back out as well. But first, we're going to just cover bits and bobs of configuration and what you can do with that builder to start off with, and the app as well. So with the builder, you can actually, instead of passing just the args into it, you can also pass in options into it as well. So you can pass options which take an args. So this is underneath, it's actually creating this anyway. You can pass an application name into it. So if you want to change the name of it, but by default, it's the assembly name. You can pass an environment name as well. And this is taking off the environment variables instead by default. But you can override it. You've got the content root path as well. And that's usually just a default directory. And also the web root path, which is where the static files, for example, would be served as well, which you can just configure. You can also configure the host. So off the builder, you have a .host, and it has a configure host options on it. You can change things like the shutdown timeout. So you can say when you kind of terminate this application, when you get a shutdown signal, I want it to take at least 30 seconds before just terminating. So if you've got some long-running quests, you don't want them to chopped off straight away. You want them to gracefully kind of complete and then shut down. So you can change the timeout to be whatever suits your business. And you can also change things like the background service exception behavior. So if you've used the hosted services in ASP.NET Core, which is an I-hosted service, I think it is, what you can do, if that gets any exception, you can just make the whole web API or the web server just terminate at that point. Instead, by default, it doesn't stop, it just continues. So if you want to kind of override that, you can. And then we've got the web host options as well. This is to configure things like Kestrel. So you've got configure Kestrel. You can turn the server header off so it doesn't give you, saying it's running on Kestrel. You can disable response header compression, and you can change the limits of max current connections. So if you only want to serve one connection at once, you can do things like that. So there's a bunch of configurations options all in here, and obviously I'm not going to go into more, but it's just kind of show you they all kind of hang off this builder. And you can also replace the server as well. So by default, it runs on Kestrel, can on Kestrel, but also can run on IIS as well if it's got certain variables set. But you can also change the web server to be something else. And this is how the AWS Lambda kind of injects into the ASP.NET Core pipeline if you're using Lambda for ASP.NET Core. It kind of just does this, which is kind of pretty magic. And then we've got binding options for URLs as well. So by default, it hosts on localhost 5000 and localhost 5001. But it can be configured in different things like the code, the command line, configuration, environment variables. And these are really similar to the old style way as well. So for command line configuration and environment variables are all the same, but the code's a bit different. So in code, you can, and when you call run, you can just pass in a string, which is what you want to bind to. So that says bind on all IP addresses on port 80. You can also do app.url. So if you've got many of them, you can add them to a list of them as well. So that says bind on any IP address for 3000 and 4000 port. And then you can also do the .NET run -- URLs. So this is more if you're debugging it locally, not when you run it in production. And then there's a bunch of them. So these are all pretty much the same. So there's localhost star plus and 0000, and they all mean listen on all interfaces. I have no idea why they actually, there's so many ways to do the same thing, because I think that this one, to me, is the right one. But it's weird. So we're just going to go into the middleware bit. So this is very similar to the normal middleware for ASP.NET Core. It literally just hangs off the same interface. So all your normal middleware, you can just hook onto the app. So you've got authorization, authentication, cores, forward headers, HSTS, static files, all that kind of stuff. So they all work exactly the same. It's the same interface what they hang off. And then the configuration is the same iConfiguration object where you're configuring, iConfiguration builder. So you can go clear all the sources, you can add command line arguments, you can add environment variables, so you can do the same thing. So this is the same way as what you do in the program CS currently, but you can it just kind of hangs off the builder, which makes it nice and easy to find. So you can do that. And you can also read it after it's built as well. So once you build your app, you can do app.configuration, which is your built configuration object. So this just gets the message from the configuration, either it be like from the config file or environment variables, and just displays it in a GET request. It's the same one. It's weird. You can also get typed ones. So if you've seen a talk I've done before on .NET configuration, you can get typed objects as well. So this is getting a typed message options, and then you can just pass that down instead. And it'll bind that from your configuration. And then login is very similar. It hangs off of Builder as well. So you have login. You can go clear all the log providers and then just go add Serilog if you want, or add a bunch more, whichever you fancy. So that's kind of where you configure them. And then once you've actually built it, you can also use the logger directly off the app as well. So that's the built logger. And then they output as you expect them, with like warnings, failures, and criticals and stuff like that. And then the last one is dependency injection. So services hang off Builder as well, and you get all the normal kind of add transient, add scoped, add singleton, and any other extension methods on there as well. So that I can't remember the interface for it, but the interface which is used for the services normally, what it gets passed into the, I think it's iService container. Oh, I think. Yeah, it's just exactly the same interface. So everything what used to hook off of like the services project, well, the services class in the startup CS is just the same one as that one. So they just continue working. And then once you've actually used it, you can create a scope on it on the app, and then just go get the service provider and get your service and just do things as well. So if you've got some startup logic what you want to happen before running your application, before your API starts up, you can just write it like that as well. So I'm just going to do a short demo of that. I'll probably just do the dependency injection one because that's the simplest one. So we've got our builder. Let's go create some classes. So let's go create. So say we've got a class here, what we want to inject into this builder. We can just do builder.services.addTransient, go add that in, and then we can just go app dot. Create a scope on the back of that. So that should output our city. So if you go to make this and start again, it outputs Sheffield because it's just got that dependency linked into it. So that means we can just add up more dependencies. So you can have a city provider or something, and then you create that. And then chain these together. Because why not? So then we got our transient my static strings with a city provider, and then when we ask for just the city provider, it'll wire it all up for us as well. So that should work exactly the same. So all the kind of IOC stuff is just exactly the same as you'd expect it to be. So next bit is on request handling. So this is the stuff coming in from some external request, and you're binding it to be handled in your application. So routing requests first. We have a bunch of, to map to the verb, so we have like a get, we also have a post, we also have a put and a delete. So these are just kind of overloads, extra methods on an app. I think it's just extension methods. We don't have a patch yet, but that's in .NET 7. But you can also get to map any methods as well. So if you want to handle a head request, you can then just do whatever you want as well with that as well. But all these kind of just dangle off the end of app. We have root parameters as well. So similar to the root parameters when you do the attribute of HTTP GET in the controllers, we can just pass them in here as well. So we can do user groups / curly brace user group ID / event / ID. And then they'll magically get bound to these things. So we can bind it to an int of a user group ID and an event ID, and then output them there like that. And that'll just kind of magically get passed along. We also can use root constraints as well. So for this example, this is saying the user group ID must match a regex of starting with an A to Z 1 to 15 times until the end. And then the events ID is just an int, so that'll have to be an int as well. And if that doesn't get matched, it doesn't get bound into this, that root doesn't get evaluated. So if we did a request to user groups.netsheff / event 5456, we'll get an OK, and I'll get some response back from it. And then if we did a one without matching the root, so this is the root here, because this is not matching our A to Z 1 to 15 times, this isn't actually matching any requests, so you get a not found instead. A lot of people think you'd get a 400 bad requests, but this is not model validation, this is root evaluation, which is a bit different. So that's why you get a not found. And there's tons of root constraints, and you can create your own as well. So you can create custom ones on the back of these, but these are all the same root constraints what you'd use in your controllers as well. So they're quite normal. The other thing what we get is link generation as well. So on a controller base, you have a URL object, which you can get string representations of routes for actions, routes, and other things as well. But within minimal APIs, we don't have a base class or anything. So what we get is this link generator. And what you can do with this, so with our map get, we can chain it with name. So you can give this a name here and say, this endpoint, we're going to call it user ID. And then we can pass in this link generator into our method here. And then we can just do linker.get path by name and pass in the name of the actual the endpoint, so this one up here. And these are just strings. And then you can pass in the values what are required for that endpoint. So this one requires a user ID. So pass in the user ID to it, and then it'll actually generate as a URL to that path. So you're not hard coding paths in your application, you can just generate them at runtime. So parameter bindings is the next thing. So when a request comes in, so you've got a payload and a bunch of other stuff like a query string, some root values, we can bind to complex objects from them things. So the way we can bind it, we've got a bunch of sources. You have the root values what are coming in. You also have query strings. You've got headers, and you've got the body, which is usually as JSON. And then you've also got the services provided by dependency section as well. And then you can also write custom ones. So these are kind of magical ones what get bound by default. So these are HTTP context, HTTP requests, HTTP response, and the cancellation token, and the claims principal. So as you can imagine, the same reason as before, we don't have a base controller to work with. So you can't just do controller.context, the this.context, to get the context and to get the request and the claims principal. So if you do this.user, you'll get the claims principal. But we can just inject them into our function. It'll pass them in by magically for us. So this is a bit of an example. So we call in a post method here of /events, we're taking an event itself, so this is coming from the body of the request from JSON and getting deserialized. We're taking the I event store, which is coming from the IAC container, and we're kind of passing a cancellation token, which is coming from the framework magically bound together. So then we can do a save and return the event. But we can also explicitly say where they come from as well. So we can annotate them with attributes and say the event comes from body, the I event store comes from services, and then the cancellation token and the claims principal and the HTTP request ones don't have anything to kind of nominate where they're coming from, so they just kind of magically end up there. And that'll work exactly the same as the previous one, except for one's implicit and one's explicit. And the only reason why you'd use them, why you'd favor this over the other one really, is if you've got like, you don't want to accept your event data being passed into your query string, for example. You always want it to be passed into the body of the request. I'm going to skip over this demo because I might do some more demos later. So we can go into that a bit further. You can also bind, so how we pass in that event, it binds it from the JSON object. We can also magically bind it from other things as well. So if we've got an object we want to kind of bind to, we can create a TryParse method on it, which passes in a string value. So what this does is go through the headers and the query string, etc., and passes a value into it. And if it returns true, so it can get that value, it will then kind of use that value what you passed out to it. And then the other one is you have another overload of it, which has an I format provider as well in it. And if you want something a bit more complicated, you can just take in, you can use a BindAsync method instead, and take in a HTTP context, and that can then go do anything you like, read the headers, read the query string, anything you want. And there's also an overload of that, which get the parameter info as well. So that's the parameter info, the method signature parameter, which you're binding to. So maybe you've got two properties on it, and the names are different on them. So you might have event 1 and event 2, and you could distinguish between them using that parameter info. But these are just magically found. So what it does is just kind of look for these methods by convention. So we've gone through all the kind of routing coming in, and we're going to just go through the responses going back out now. So everything which is going back out can either be a string, any type, or an I result. From them, you can either have it wrapped in a task or a value task as well. So if it's asynchronous and IO blind blocking, you can pass a task back and then the framework will wait on it. Pretty much the same as in your controllers. So that means all these kind of work. So you can pass a string back, you can pass an object back, so that is just using an anonymous object, or you can pass a result and do .ok to it, and that'll give you an I result back from it as well. So that's very similar to like an I action result in the controller world. And the result object itself has a load of static factory methods on them. So it has OK, not found, no content. So these are really similar to all the kind of methods on the base controller. But because we don't have a base class again, we just have a load of static factory methods on the result object to kind of deal with them. And then the next bit is just authorization. So authorization is simplified, and you can use this in the normal ASP.NET stuff as well. You can just use authorization. Oh no, sorry, I was thinking about .NET 7 features. But yeah, so the authorization thing, you can just add a authorize attribute to it, or you can add a method chain in call of required authorization. And I kind of prefer this kind of syntax over the attribute, just because I feel like it reads a lot better. And then that'll have to be authorized to call that endpoint. So that's all the kind of stuff in .NET 6. So the next stuff we've got coming up is the .NET 7 features, which are going to be released next week, I think it is, which is the .NET Conf, the release in that. So as I said, we have the patch thread. That's the most unexciting one, which you could do anyway, but it came out in preview 1. It's the first thing that they changed. We have a iForm file we can bind to instead. And then from that, we can copy that form file that's coming from the request to anywhere we want, so we can stream it somewhere else. And the reason behind this, why we got this now, is that we can just be a bit more like memory efficient with kind of what we take streaming the data in and then streaming it back out somewhere else. Then this is similar to like Node. We can also take in a stream, and we can take in pipe readers as well. So the same kind of principle, we can just like go get the body as a stream and just copy it and stream it somewhere else, straight to a file or over the network somewhere. We have a bunch more like descriptions and summaries. So these are useful for Swagger documentation. So you can do a dot with description and pass in the description of that endpoint. We can also use this attribute of endpoint summary as well, but also I'd rather do the method chaining one to be a bit more fluent. You can bind to arrays now. So before in .NET 6, you couldn't bind to arrays. So if you've got multiple parameters on your query string, you can just bind directly to them. So that'll take a tags. That endpoint's tags will take a Q1 to Q2, Q3, and that'll be 1, 2, 3 in them variables. And it also can bind to these string values as well, which are this is the string representation of them. We have endpoint filter delegates. So this is one of the main kind of features in .NET 7, which is really good, I think, personally. So these are for cross-cutting concerns like validation, logging, etc. And you can add in a filter. So this is just using the inline delegate. It takes a root handler invocation context and the next. So all this is saying is pretty much validating this name up here is, so it's validating that name argument up here is, if it's Bob, then we want to return a problem JSON saying no Bob's allowed. So that's pretty much just validating my model coming in. But you could just use that for anything. You could pass that through to like Fluent validation or the attribute validation in .NET to validate your models coming in instead. You can also encapsulate that as well in a filter as a class. So you have to implement an endpoint filter. And then it has one method where you have to implement called invoke async. And it just passes exactly the same arguments into here. You have the root handler invocation context. And then you can just check the same value, and that'll just work exactly as before. So then you can add them filters by just doing a new filter and passing into the add filter. Or you can just pass it as a generic argument and it'll create it itself as well. We have results.stream for streaming things out. So we had the streams coming in. We can also stream things coming out. So if we're reading something from network or from disk, we don't have to read it all into memory and then stream it back out. We can just like stream it straight across to be a bit more memory efficient. And then we have typed results, which are really cool, I think. So in .NET 6, we only had a result.ok, and it just accepted anything into it, just as an object. Now we have a typed result.ok, and you pass in a generic into it, which means you can omit off this because it's inferred, so you don't have to pass a string into it. You can just pass the string into it, and it'll infer that generic. But that means, like when we're doing type checking in compilation time, we can get errors back out of our methods as well, about compile time errors, such as this. So this example says we can have 2 results coming out of this method. We can have an OK, which is a string, and a not found. And then this results things has multiple arguments to it. So if the ID is 0, we can do a typed results.notfound, or we can do a typed results.ok hello world. And that will compile. But if somebody comes along tomorrow and says typed results.no content, then it just won't compile because it doesn't abide time types, which is quite cool. There's a bunch more kind of extra OpenAPI improvements. So with I think it's operation builder within the old way of doing it, you now have a method which you can just chain onto your endpoint. So you can do a with OpenAPI. It gives you the operation, and then you can just change anything on that operation. So you can update the summary, you can change the first parameter of the operation to say allow empty values to be false. You can just change anything. So the actual Swagger OpenAPI documentation, or how it's been generated, is just right next to the endpoint, which I quite like, to be fair. You can also annotate your models a lot easier as well. So within C# 11, we're getting static implemented interfaces. So we can have static methods on our interface. So this is an iEndpoint metadata provider and an iEndpoint parameter metadata provider. And if you implement these on your model and implement the static method, that'll give you more context for the OpenAPI generation of that for that model documentation. So then your OpenAPI documentation stays with the model itself, which is also quite nice. We have root groups as well. So in .NET 6, we couldn't do this, but now we can just do map group. We can say map a group of /people, and then on that people, we can do a /get, we can do a /id, we can do a /post, and then they'll all map at the end of the map group, which is a lot nicer and cleaner. Authentication, you can just add JWT bearer tokens by just calling add JWT bearer. And if you pass in this into your configuration, into your app configuration of the audiences and the claim issuer, it'll just go validate it because all JWTs pretty much get validated the same, and this is the default standard now. So just kind of wrap that up, just going to make that a lot easier. And then authorization becomes a lot simpler as well. So I don't know if anybody's, the recommended way is to use policies inside your controller endpoints for your actions. So you do authorize and do the policy name, and then in your startup CS, you declare a ton of policies. And it's really hard to kind of match them both together, and they're kind of really disconnected. But with minimal APIs now in .NET 7, we can do this required authorization, and then you can pass in the policy what you want it to kind of evaluate. And this will create your policy for that given endpoint as well. And you can also use that policy, the require authorization, to your map group as well. So if you have like /admin, you could say, this is only admins allowed. We have an extra thing called API parameter as well. So we can bind all your kind of objects where you want to have in your method into one object instead. So as you can imagine, if you've got stuff coming from the headers, the body, you've got a load of like DI stuff as well, it can become quite big. So it can be wrapped up into a class itself or a struct. And then you just annotate the properties itself as well. And this can be a record as well. And then you just pass that one parameter into your function for your endpoint, and then it'll just kind of bind that directly to it. So map group also supports loads of other normal extension methods on the back of it as well. So you can do .with tags, with API, OpenAPI, with description, and all that kind of stuff as well. And that'll give you a baseline for all the rest of the endpoints as well. And that's pretty much it for all the kind of features of minimal API. The next bit is just the testing minimal APIs. And with testing it, it's just the same as before. So you test minimal APIs exactly the same as the normal ASP.NET controllers, because it flows down the same bit of middleware. The only difference is you need something to hook onto, which is like publicly exposed, for which the web application factory can use. And that's pretty much it. I'll just give you a quick demo of the testing of it, and then we'll wrap up. So you've got this. So this is our app at the moment, which has the / and the /dotnetsheff. We can go. So we need to create something to publicly expose this object. So we can just create a public partial program. Is that you? Why isn't that working? Oh, yeah, that. Put things in the right place. Yeah, so that'll just make it, so it's internal by default, I think it is, or private by default. So that'll create the program.cs file which this is getting compiled into as being public. And then we can use that in our test. So we can go create a web application factory. Has anybody used the web application factory before? Yeah, most of people. So we can go take a reference of. That's not what I want. So you can go take a reference to this. We can go get the HTTP client from what it creates. And then we can just call the get as if we're calling our API. Yeah, we need to wait on it. And then from that, we can just go read the content. Read a string. And then we can do check that as what's the thing? So we can go check that expected. I don't really know what we put in it. 1 second. We put it as hello.netsheff. So we can go do that. We can check that body is equal to that. And then we run this. It'll just test our API. So if you can see. So we've got the test passing there to say that that's actually doing a get to the slash will pass. So then if we go break our implementation, say hello world, and then run this test again, it should break. So then we can't go to production. So that kind of all just kind of works exactly as it did before, which is pretty cool. So if you're kind of migrating from controls into minimal APIs, you can just do that and your tests will continue passing. But yeah, cool. That's pretty much it. So we went over the traditional APIs, what we're all used to. Went over a bit of a kind of hello world application, how we can configure it, the requests coming in, responses going out, a bit of authorization, how we can test it really. But that's it. So thanks for listening.